Greetings and welcome back to the channel. So today I'm going to be talking about quantum physics. So this is a subject that is dear to my heart because once upon a time, long ago, I was in fact a quantum physicist. Well, technically I still am because it's not the sort of thing you can just shake off. I wrote a 120-page book for my PhD thesis, and in this book is all quantum physics. Nuclear physics is an application of quantum physics, so you've probably heard me say I'm a nuclear physicist or a quantum physicist. I mean, the two are really interchangeable. It's the same thing. Nuclear physics is an application of quantum theory to the model of the atomic nucleus and nuclear reactions. So yeah, I did it, and I got the doctorate. I sat for 3.5-4 hours and got grilled by 4 senior professors on every detail of that, and but I got through it, and so that was over 20 years ago. Now, the fact is, I do know what I'm talking about when it comes to quantum physics and nuclear theory. And though I am very skeptical of it now, and though you may well disagree with my opinions on it, I just want you to know that I do know what I'm talking about. And I have sort of earned the right to comment on the veracity of quantum theory because I devoted like a large chunk of my life to it and got a qualification in the subject. So, I'm not doing this to annoy anyone. I'm doing this simply because this is what I studied and this is my view on it as a scientist myself. So, just to get that out of the way, but there's also another caveat that I have to say as well. So it's important to understand that when I start criticizing and debunking a lot of the quantum theory and the atomic theory, I'm not saying that everything in here is wrong. In fact, I did actually do some good work in here, but here's the thing that you have to realize is that quantum physics is based on classical physics. So quantum mechanics is based on classical mechanics, specifically the Hamiltonian formulation of classical mechanics, which is like a generalized version of Newtonian mechanics. So, and when reactions are modeled, what is actually used to model the reaction is wave functions, or just wave forms, just like the same mathematics that goes on inside a synthesizer. And so if you're looking at something like you've got a laser beam, and you're firing a laser beam at a certain substance, and you want to know where the energy is going to go after it reacts with that substance, you can do that using waves, purely just using wave theory. Now, so quantum theory has all that within it. The classical physics and the wave mechanics are still within it. So it does work to an extent on predicting outcomes of measurements. And that was really, for me, when I was taught quantum physics, that was what I was taught to think of it as. Just a tool for predicting the outcome of measurements. I know because I did the work, you can actually predict the outcome of measurements using quantum physics. However, what I learned in my thesis was that it's not the quantum part of the theory that is giving the results. It's the classical part. It's the classical wave mechanics. Vibration, energy, frequency, right? This stuff works. It's a very, very precise science. And so quantum mechanics has all that within it. So when I criticize or debunk many of the claims in quantum physics, I'm not saying that every calculation that every scientist has ever done is wrong. It's not the same thing. Try to understand there's nuance here, okay? When we approach something like quantum physics, we have to think of it in really three distinct parts, like the three parts of the work in alchemy. You have philosophy, theory, and practice. So the philosophy is the belief systems and the creed that led to the development of the theory. And of course, the practice is what's actually done with the theory and done by those people who believe in those philosophies. The philosophy is the belief systems, the theory is the thoughts, and the practice is the actions. So when we look at something like quantum physics, we really have to break it down into the philosophy of quantum physics, the theory of quantum physics, and the practice of quantum physics. Now, I was trained in the theory and practice of quantum physics. And I was just lucky in my final year, I had some credits that I needed to make up. And there wasn't really anything in the physics department that I wanted to do. And so I asked if I could do a course in the philosophy department. And of course I got laughed at first. But I said, well, it's philosophy of science, so surely it's relevant to my degree. And they were like, all right, fine, we'll let you do it. And so like me and one other guy, we went and did a philosophy of science course in the philosophy department in final year. And I learned a lot about the origins of these theories, and I learned about how people saw things before these theories came along. And that's very valuable information, because when you're just in the science degree, you're not getting taught about the philosophy of where it all came from and why people came up with this and why people think this way. You're just getting like sort of hyper specialized in the theory. And so I always had this sense of the bigger picture of the history and philosophy of science as well, and how our view of things has changed over the centuries. Quantum mechanics is really about 100 years old or so, and it's a theory that's talked about a lot. It's used by people to explain things that they can't otherwise explain. So it's like there's a quantum card, if you like, and a lot of people play the quantum card. When they need to explain something, they just bring out the quantum card and they say, it's quantum, therefore, this and that, right? Make some claims, because the quantum card is really, it can be applied to like any type of science. And, so we have quantum everything now, all right? It's not just quantum physics, there's quantum chemistry, there's quantum biology, there's, quantum everything. There's a quantum world. It's a whole other world from the world in which we live in. The quantum world is another world entirely, one which no human being has ever experienced, might I add. So it's a theoretical world, another dimension existing at very, very small scale of reality. And it's been hypothesized and talked about for the last 100 years or so. So where does it come from? What is the philosophy behind it? And also, what do they actually do? We hear a lot about the theory, but what's the philosophy behind quantum physics? And what do they actually do? Well, I'm going to talk about that today. All right, let's get into it. Let's just look at some of the criticisms against quantum theory. Now, one of the main ones is that it's lacking real-world applications. Now, this is a big one because if a theory has no application, then, it really ought to be scrutinized heavily, and, we need to decide whether it's even worth continuing to research the theory if it's not able to produce any applications or fruits. So quantum physics has a real lack of real-world applications. And while there are plenty of people who use the word quantum in their products and in their explanations and descriptions, you definitely got to use your discernment, because in every case that I've seen, there's actually nothing quantum going on at all. The word is just being used to sort of bolster something, to make it sound more powerful or mystical or magical. So an over-reliance on Gedanken experiments. This is thought experiments, and that is one of the things about quantum physics that makes it different from normal science, you might say, is that a lot of the experiments were never actually done in a laboratory. They were just done in somebody's mind. And, I read a lot of quantum physics thinking I was reading about experiments that were actually conducted, and then later found out that they were just Gedanken experiments run through in someone's head. So it's too open for interpretation. So it's often criticized as not really being a hard science because it's, you can sort of say anything you want about it. It's got a kind of fuzzy logic built into it that lets you kind of run wild with your imagination and still manage to justify it. It's incomplete as a theory. It doesn't really, it doesn't tie up the loose ends. There's actually an incompleteness theorem about quantum physics. It's unintuitive and really indecipherable for, most people. It relies on spooky magical action at a distance. Okay, so this is the idea that one object, a particle, can affect another object that's really far away at a distance without exchanging any matter or data. That just somehow through some spooky action, they're able to influence each other. So this is kind of built into quantum physics, and it's also built into the theory of gravity. Indeed, that is what the theory of gravity is a theory of magical action at a distance between bodies with mass. So the measurement problem. Now, this was the subject of my master's dissertation, which I don't have a copy of right now. I think it's in my parents' loft. But the problem with the measurement problem is interesting because it basically says that if you try to measure a quantum system, the very act of measurement itself will cause the quantumness to disappear. So, in other words, it's this idea that when you look away from something, it's all quantum, but then when you look at it, it becomes real. And this is a problem. So essentially, we're told that there's all this like quantum behavior going on, but whenever we try to measure it, it just behaves like normal classical reality. So there's the problem of the random universe. So quantum physics suggests that everything comes about through the random interactions of atoms and particles. And this, of course, is a nihilistic worldview. It's very unsatisfying, and it's completely indefensible intellectually. And even Einstein didn't subscribe to this. He said, "God does not play dice." So decoherence, well, this relates to the measurement problem, and this is the idea that we can't observe a coherent quantum system because it kind of collapses to a classical system upon being observed. So, it relates to the measurement problem. And then we've got the double slit experiment. Now, I'll come to this in more detail, but we're told that it proves that waves can be particles and particles can be waves, and that these are like interchangeable. Now, the problem is it actually doesn't prove that. If you go at it with a bit more of a skeptical mind, and I'll do that in a little while. There's Brownian motion as well, which is Einstein's theory of the wiggling of stuff. So they were looking under the microscope, this Brownian motion, which was like this little wiggling motion that you would see in like biological samples. Like if you look at them under a microscope, there's all this like everything's like sort of wiggling, these little globules and stuff. Einstein proposed that wiggling was caused by atoms. And, it wasn't really an experiment. It was just simply a theory to explain the wiggling. But it's actually the heat. It's the heat that causes the wiggling, because if you take the heat away, then there's no wiggling. But Einstein said, no, it's the atoms that cause the wiggling. And so he called it the molecular kinetic theory of heat. And this was said to have proven the existence of atoms. Everyone's like, yep, Einstein said it, so it must be true. Okay, so then there's quantum computing. Now, quantum computing is vaporware. I've been learning about this for about 30 years. And they were saying the same thing 30 years ago as they're saying today. It's the same story that's played out about quantum computers. It's the same narrative, but it's actually never developed. There's been no advances. There are no quantum computers. There's no evidence of quantum computing or qubits. It's a complete hoax as far as I'm concerned. It's vaporware. It's technology which is always on the horizon but never materializes. I'll come to that a bit more later. Then there's the idea that quantum mechanics is actually just ancient atomism rebranded. So atomism is an ancient philosophy, goes back to Greek times. And, there's a particular sort of philosophical belief system around it, which is, very hedonistic and atheistic. And, this is essentially quantum physics is sort of like a rebranded modern day version of this ancient atomism. And so it leads to a phony hedonistic spirituality. And this is because the ancient atomists were hedonists. It was like part of their whole life philosophy. So the theory of the atom is actually connected to hedonism and nihilism and atheism. And so when we start believing in quantum theory, we are like being initiated into a phony hedonistic spirituality. So it's basically just too woo, as far as I'm concerned. So the whole thing is just too woo. There's a lot of like woo-woo claims and stuff that can't be verified. And, it needs to be reined in a bit. So what is ancient atomism then? Well, the idea that everything is reducible to atoms in a void is attributed to 4 ancient figures: Leucippus, Democritus, Epicurus, and Lucretius. Now, I'm skeptical that Leucippus and Democritus even exist, to be honest. But Epicurus is the founder of Epicureanism, which is this sort of ancient New Agey philosophy that's like all about seeking pleasure, maximizing happiness, like avoiding fear, and so on. And they were very much into atomism. And, Democritus, strange. I mean, again, skeptical that he really even existed, because he doesn't appear to have been known for anything other than atomism. When I first heard the name, I thought, Democritus, that must be who gave us democracy. But then I looked into it, and he never said a damn thing about democracy or politics, or in fact, anything at all, except atoms. But there's no surviving writings. So he could have just been written into history by the Romans at a later date. Either way, we're told that Democritus and Leucippus were like the fathers of the atomic theory. And, Epicurus kind of ran with this and created a whole like hedonistic philosophy around it. So, well, what is it then? Well, it's based on 4 core belief systems, which is determinism. And that's the idea that the motion and interaction of atoms are governed by natural laws, not by divine intervention. So no living God, right? So no God that can actually influence the world, change things, or, even move a single atom. Materialism, well, that's the idea that everything, including the soul and the mind, is made from atoms and disintegrates after death. so no eternal soul, afterlife, or judgment. Hedonism, life is about the pursuit of pleasure, happiness, and the elimination of fear. So this is no sin or moral duty. So the idea there's no consequences for actions, or there's no like moral duty upon us to like do the right things or to suffer. And then nihilism. Well, phenomena are said to arise from random motion and interaction of atoms. So no purpose, no meaning or guiding light. It's just everything happens because nothing. There's nothing behind it, right? It's very, very nihilistic. So, these are belief systems, these are creeds, these are the ancient philosophies that are underpinning the whole entire atomic theory. And then realize, of course, that the atomic theory is the bottom layer of the entire structure of modern science, physics, chemistry, and biology, all based on atomism. So it started as an ancient Greek idea, as we're told. Someone just thought, maybe everything is made from tiny indivisible particles floating in a void. Just an idea. Aristotle wrote extensively on science, philosophy, and logic, and explained everything in terms of the 4 elements in the ether. This was the established scientific paradigm worldwide for at least 2,000 years. But then there was a revival of atomism by the Romans in the 17th century. And this is the Venetians, the Jesuits, Galileo, Boyle, Newton. People like this, they opposed the Aristotelian logic and the physics of fire, earth, air, and water. And they reformulated science in atomic, materialistic, and heliocentric terms. They called it the scientific revolution. Okay, so you will have noticed that the model of the solar system and the model of the atom are nearly identical. It's because essentially the solar system, the cosmos, has been modeled as a giant atom. But the atom is really the underpinning philosophy, belief system. It's a kind of like it's like an idolatry. The atom is an idol for science believers. And then, so there was the pre-quantum atom, right, from like the 17th through the 19th century. And in the pre-quantum atom, it was indivisible, uncuttable, and impenetrably hard balls of matter. So 100% solid stuff, just tiny little, really hard bits of stuff that you can't break. Well, in the post-quantum atom, so after the quantum theory came out, the model of the atom changed. And they started to say, well, it's divisible. Actually, it is divisible. You can cut it into pieces. It's actually just made up of loosely bound particles, all kind of like whizzing around each other, all these different flavors of particles. And those particles are kind of phasing in and out of reality. They're like sometimes there, sometimes not, sometimes a wave, sometimes a particle. And actually, the whole thing is like 99.9999999% empty space. so you see how the conception of the atom is like completely changed from 100% solid stuff to 99.99% empty space. So it's almost a complete inversion of the conception of what the atom is. All right, so let's talk about some of the cornerstones of quantum theory. So, first one is the discovery of the electron, 1897, by J.J. Thomson. Now, essentially, he was working with cathode ray tubes, which are these vacuum tubes with a fluorescent glass. And when you apply a direct current across the tube, you get this beam of light going through the tube. And he observed that when he held up a magnet over it, that the beam would bend in the magnetic field. And so on that basis, he concluded that the beam must consist of tiny charged particles, negatively electrically charged particles called electrons. So I wouldn't say that he actually proved the existence of the electron. It was really just a theory of what these cathode rays may consist of. Now, there is an issue with the whole idea of a negative electric charge, like a static particle which emits an electric field. It's because electric fields are intimately tied to motion. Electricity is created through motion. It's like fire and air. Alchemically, it's all about fire and air. And whereas you have magnets, which are static, electric fields are created by motion, either like moving magnets or by like friction, or, you know, there's always got to be some motion which is sustaining the electric field. So it's kind of an oxymoron, this idea of electrostatic. It actually means motionless motion. So, you know, I put the question out to you. I mean, are electric point charges physically possible? You know, you sit in physics class and they say, well, if you have a point charge Q and it's this distance away from another point charge Q, then what's the force between them and all this? Well, where's the point charge Q? Have you ever seen a point charge Q in your life, right? There's no particles of electric charge in reality, right? It's a theory about what the electricity or the light consists of. Now, we also have the quantization of energy, or the quantization of light, and that's in 1900, and this is the Max Planck and the ultraviolet catastrophe. So, well, this ties to the theory of black body radiation, and I'm not going to get too deep into this, but I'm just going to tell you my opinion on it. That it is essentially a mathematical trick that was designed to discredit classical physics. The ultraviolet catastrophe is not a real catastrophe. It's just kind of a made-up problem, because it's all based on this idea of a black body radiator, which is, again, a completely hypothetical type of material. There's no such thing in the real world as a black body radiator. So they created a model for this black body radiator and sort of set it up in a way to make it seem like classical physics had reached its limits and was now no longer able to explain reality. But it's, you know, it's just a trick. And but then the idea is that they then solved the catastrophe by quantizing energy. So by deciding that light is made from particles called photons. So, yeah, this whole ultraviolet catastrophe, black body radiation thing, I think it was Planck himself used the term mathematical trick, that he thought it might be a mathematical trick. It is a mathematical trick. But anyway, this was the basis on which it was declared that classical physics was no longer able to explain things. And we needed a new type of physics based on quanta, the idea that everything consists of these tiny little pieces. Now, Brownian motion, this is Einstein's atomic explanation for the thermal jittering of fluids. So it's also known as the molecular kinetic theory of heat. So as I mentioned before, this was the jittering of fluids that was observed under microscopes. Einstein proposed a theory that the atoms themselves were like causing the jittering which was being seen under the microscope. But this was just a theory. It's an intermediary, if you like, because what's actually causing the jittering is heat. Because if you take away the heat, there's no jittering. So the heat is the independent variable that you control to decide how much jittering you get. Einstein came along and said, well, there's in between the heat and the jittering, there's these things called atoms, and they sort of take on the energy from the heat and then cause the jittering that we're seeing. So he just kind of basically inserted atoms into the middle of that process, and we're told that kind of settled the debate over atoms. That was it. It was like settled. Everyone now knows atoms exist. All right, so the photoelectric effect. So this is the theory that electrons are ejected out of their atomic orbits by photons. But what's actually happening in reality when you do the photoelectric effect demonstration is you shine a UV light onto a metal surface, and that surface then begins to conduct, to generate current. So, that's what's actually happening there. But again, this theory of electrons and atoms and photons has been inserted into the middle. So now they will say, well, it's ultraviolet photons which are ejecting electrons out of their atomic orbits, and then those electrons are then being swept up in the metal, which is why you get the current. Okay, so, I think there's just two ways of looking at that, right? It's just like it's ultraviolet light and electricity, or it's photons and electrons. Well, ultraviolet light and electricity are real. They exist in the real world. Electrons and photons are hypothetical. So the discovery of the nucleus, all right? So Rutherford did this gold foil experiment where he essentially had a sheet of gold foil and a radiation source and then some detectors around. And some of the radiation went right through the gold foil and some of it bounced back. And essentially he concluded from this that the gold foil contained something called a nucleus at the center of all the atoms, which was this really, really hard, heavy piece of the atom. And this was what was causing the radiation to bounce back, because he believed that he had a source of alpha particles, which are helium nuclei. And again, I would question that. Did he really have a source of alpha particles, or was it just emitting light? Some of the light was going through and some of it was coming back, like high energy light, UV light. I suspect it's the former, the UV light. Again, no proof of alpha particles. Okay, then Young's double slit experiment. And yes, it is called Young's double slit experiment, but it's not me. It's Thomas Young from 1801. So this is a simple demonstration that really, anyone can do in a physics lab or even at home. And it proves that light is a wave. But in quantum theory, we're told that this experiment has been done with particles. And the fact that it can be done with particles proves that particles can behave like waves and waves can behave like particles. So I'm going to come to that. Okay, so Young's double slit experiment. Simple demonstration to prove that light is a wave. One beam of light is split into two, and the crossing of the beams at different angles creates these interference fringes. The size of the spacing between the bands relates geometrically to the wavelength of the light, the size of the slit, and the distance to the screen. Okay, so you can see in the image there's two light beams which are diverging from different sources. So originally it's just one beam, and then it goes through two slits, which splits it into two beams. And then the beams diverge outward from the slits. And as they cross over, there's a screen. And on the screen, you get these like bright patches and dark patches in a wave-like pattern, like a sine wave. And this proves that light is a wave because it actually relates to the wavelength of the light. You can use it to calculate the wavelength of the light. It can be done with sound and water waves. So the problem is that quantum mechanics claims that this can also be done with electrons, fired one at a time like BBs. And that the same pattern will build up over time. So if you look over at the image there, the dot map. So it's essentially saying if you get an electron gun, pew, 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 and just fire them one at a time, bam, 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 then the electrons will come up to the two slits and then do something, go through one of the slits or both of them at the same time or none of them, or who knows what happens. But somehow the electron gets to the other side of the two slits and then will always end up in one of these patches following the same pattern as the light beams. Now, that's all well and good if it were true. Now, I'd really question whether or not that's actually ever been done. And the reason is because it's actually a very simple experiment to do. But if you go diving into, how many people have actually done this experiment with electrons, it's not a lot. It's, as far as I can tell, it's only been done about 6 times in all of history. And written up into a scientific paper. And from this, they make all kinds of crazy claims. So they'll say that the electrons interfere with each other through time, right? Because they're going through one at a time, but they seem to be creating interference patterns. But what are they interfering with? So there's all kinds of theories that they're interfering through time, or that they split up and interfere with each other in just ways that completely defy logic. Quantum mechanics claims that this is evidence of single electron interference based on a handful of experiments. But the same effect can be achieved with low intensity UV radiation pulses. So let's say you have a low intensity radiation source, like some depleted radium, let's say, and it's just emitting pulses of radiation every so often in a sort of random way. Well, you can do this experiment and you would get this, you'd get exactly this kind of effect, because radiation pulses are in fact waves. We've been conditioned to think of them as photons, but it's not the right way to think of them. They are waves. Like a pulse is still a wave. You have continuous waves, which have, say, no beginning and no end, just like a continuous wave. And you have pulsed waves, which have a particular duration. They have a wavelength, a frequency, and a duration of action, a beginning, middle, and end, or attack, decay, sustain, this kind of thing. So, yes, pulsed UV radiation will produce the exact same effect. So I don't think they had any evidence that they were working with electrons, and that the effect they report could be done with just a low intensity UV radiation source. What about interpretations then? So I said it was open to interpretation. And yes, well, there's many different interpretations of quantum mechanics. The one in which I was indoctrinated would be called the Copenhagen interpretation. And this is the idea that it's just a tool for predicting the outcome of measurements. So you're supposed to just avoid having any conversations about the fundamental nature of reality. At the physics conferences, when the wine starts flowing and everything, it's you're advised not to bring up quantum mechanics and what it all means, because things will get ugly, right? It's you got to just avoid that kind of conversation and just do the work. And they have this saying, "Shut up and calculate," right? It's just just shut up and just calculate. Do the sums, right? So that's very much the way of looking at quantum physics that I was taught. And as I've said, it does actually work as a tool, for predicting the outcomes of measurements and stuff like that. Working with beams of light, incident on certain substances and everything, but it's all because it has classical wave mechanics inside of it. It's it's not a whole new physics. It's just it's like a shell that's been put around classical physics. Okay, so the many worlds interpretation of quantum mechanics. Well, this is very popular, and it went on to be, a big hit among sci-fi TV writers. And this is the idea that there's infinite parallel realities all acting out different possibilities all at once. So there'd be parallel selves, like parallel versions of me making different choices in other universes. And, how does this come out of quantum physics? Well, it comes out from having a sort of literalist interpretation of a statistical distribution. So these wave functions, they would have as they interpret it as a statistical distribution, and so a distribution will have many different options, or many different choices, or many different results within it in the distribution. And so from that, they conclude that every part of the distribution is existing in a universe all by itself. So it's quite a crazy idea. So there's like other versions of me in other universes doing the things that I chose not to do. So it's the idea that all that doesn't happen must happen in other universes. So this is pretty wild stuff. And, for a lot of people, of course, they just run with it and, base their whole conception of reality now on this idea of like multiverses and parallel selves and parallel realities and stuff. But, it's based on no hard science whatsoever. Okay, this is a peculiar way of interpreting mathematical equations. And, I don't think it's healthy. So we also have David Bohm's interpretation of quantum mechanics. And he had this idea that was all like one holistic, interconnected field of awareness. He was into the idea of non-locality and the implicate order. And, this was a kind of merging of science and spirituality, and, bringing consciousness into it more, because there's this relationship between the consciousness and quantum. He brought a more like spiritual dimension to the interpretation of quantum theory, and, it was popular among people such as myself, artists and so on, because it was scientific, but also spiritual, and pointing towards this idea of a unified field of which we're all a part. Now, that's always quite a nice idea to go back to, because that's the whole idea of ether from alchemy, which was like the standard way of looking at things for thousands of years in the past. So so when modern scientists like hint at the idea of a single like field unifying everything, we're sort of like, that feels good. Yeah, because we're trying to get back to the truth. So Bohm's stuff, I read a bunch of his books in university, and I found them like the most enjoyable books to read about quantum physics. He had an interesting perspective on it. Now, Young's interpretation, this time it's Stephen Young, not Thomas Young. But my interpretation of quantum mechanics is this. It's a statistical reformulation of classical wave mechanics It fails to prove the existence of subatomic particles. It's replete with logical fallacies, and it's brought no benefit to humanity in over 100 years of being, heavily funded and researched and promoted. So it's just how I see it. So let me explain a bit why I say that. Okay, so let's talk about the alleged applications of quantum theory. So we've got the nuclear bomb, right? That's usually the first thing people think of. Well, we couldn't have made the nuclear bomb if it wasn't for nuclear theory and knowledge of the atom and how to split the atom and all this. But as I'll come to in the next slide, there are a lot of issues around the nuclear narrative. And least of all, well, there's no real evidence that there's any atom splitting going on. And if there's no true atom splitting happening, then it's really not an application of nuclear theory. And, bombs are actually pretty easy to make. You don't need to be a quantum physicist or a nuclear physicist to make a big bomb. It's just a case of getting the right fuel, mixing them together, and igniting them. Boom. That's it. So this idea that you need some sophisticated theoretical physics in order to make a big bomb is just not justified. Sorry, there's never been any nuclear fallout in any of these so-called nuclear blasts. So I'm of the opinion that the bombs are not nuclear. They're just bombs, just fire bombs. So then there's electronics. Well, electrical theory is actually independent from electron theory. In fact, I've had numerous electricians have written to me and said, thank you for saying the electron doesn't exist, because it's just not helpful, guys. The electron theory is not helpful to people who work with electricity. Electricity is described in terms of current, resistance, voltage, things like this. It is described as a fluid. Electrical theory works with electricity as a fluid, an electrical fluid, not as a sequence of BBs going through the wire. That's just theory for schools and universities. Then we have semiconductors. So some people have said to me, well, what about semiconductors? Right, the basis of all modern computer tech, like that uses quantum physics, right? And if you went to university, you might have learned about it, like P doping and N doping and electrons and holes and all this kind of stuff. But again, all that stuff is taking place in the abstract, theoretical, other domain called the quantum world, which is being constructed with equations on a piece of paper. You see, so you need to come into the real world and look at what is actually happening with semiconductors. Okay, so semiconductors, silicon, is made from quartz. Quartz is one of the most abundant materials in the earth. So they take the quartz, they refine it, purify it, and transmute it to make silicon. And silicon has the unique property that it can conduct electricity when heated above a certain threshold temperature, becomes a conductor, and if it's below a certain threshold temperature, it's not a conductor. So that's why it's called a semiconductor. And because of this intrinsic property of silicon, which comes from quartz, which is piezoelectric material, and because of this property of silicon, they're able to create very, very small, thin switches, because the material is so pure and it has this intrinsic property of being able to switch between being a conductor and not being a conductor. Okay, it's nothing to do with atoms and electrons. Miniaturization. In fact, the miniaturization of technology is not due to atomic theory, it's due to engineering excellence. Then we have things like the laser. So I remember learning about laser in university, and it was all about quantum physics and electrons being excited into like higher states of the atom and all this kind of thing. But again, that was all taking place in the hypothetical other world of the quantum world, right, where logic is fuzzy. But in the real world, all that's happening is you have a light source, you have some mirrors, maybe a gas, and then a focusing lens. It's basically smoke and mirrors is what a laser is, right? It's not this thing that was like engineered from the atoms up, right? It's it's a fancy kind of a flashlight. Now, then you've got things like MRI or NMR. So I was taught about NMR, which is nuclear magnetic resonance, but in the real world, as in the hospitals where these machines are, they're called MRI machines, not NMR. They actually dropped the word nuclear from the name. It's not instead of nuclear magnetic resonance, it's now magnetic resonance imaging. So the nuclear part wasn't really important enough to keep in the acronym, and of course no one wants to stick their head into a nuclear machine as well, so it just wasn't going to work calling it nuclear. But also, you don't need to be a nuclear physicist to operate the machine. It wasn't invented by nuclear physicists. There's a theory of how magnetic resonance would work on a nuclear level, but that is not the theory that gave birth to this machine. Okay, and then finally, quantum computing. All right, well, as I've said, this is fake tech, vaporware. Those two images there are two images of the quantum computers that they claim that they have. So the first one, which as you can see is a big black box, and the second one you can see is a little black box. But if you know anything about engineering, you know that a black box is actually just a system where the internal workings are completely hidden, unknown, or mysterious, right? So they're basically showing it to you. They're rubbing it in our faces. It's just a black box, guys. It doesn't actually do anything. And every so often they'll pop up with a new design. There's some really fancy looking ones now that are all like gold with all this like stuff hanging off them like an Arabian lampshade or something. But they don't do anything. It's all propaganda. That's why it's on the BBC News website, right? They'll bring it up every so often, like every 6 months or every year, there'll be a new story about how quantum computing is just around the corner, and they're going to build the most powerful computers ever that'll be able to hack all passwords and crack all the codes and break all the encryption because it can do all calculations at once and at the same time. It's a lot of rubbish, guys. No truth to it whatsoever. I'm going to talk about top 10 nuclear hoaxes. So if as I say, there aren't actually splitting the atom, then what you have to realize is that everything nuclear is a hoax, because it's all based on this principle that the atoms are being split or that the atoms are spitting particles out of them. So if there's no atoms and no subatomic particles, and if they aren't really splitting the atom, but rather they're just trying to hype up their bombs, then everything nuclear is a hoax. Everything with the word nuclear in front of it is a hoax. So I just picked 10 of my favorite ones, but there's way more than just this. All right, so there's the bomb. All right, so yes, the bombs were dropped on Hiroshima and Nagasaki, but there was no nuclear fallout. It appears the bombs were non-nuclear. There's a guy called Michael Palmer who wrote a book about this and concluded that it was napalm and mustard gas that was used for the bomb. So they didn't even use uranium and plutonium, as we're told. If the same effect can be achieved with some readily available substance and that's more cheap and easy to use, why would they use this like state of the art highly theoretical type of bomb or material if they could just do the same damage with napalm and mustard gas. So it doesn't really make sense. The nuclear fallout, we're told, would be thousands of years of decaying matter and plant life unable to grow and mutations and body parts falling off and all this kind of thing. But actually, they built the cities right back after the bombs, and as I understand, they're thriving modern cities. Now, then nuclear power. Well, people say, well, okay, right, okay, nuclear bombs aren't real, but what about nuclear power? Well, there are obviously power stations around the place, and if you just look up how they work, they'll tell you it works like a giant kettle, which is where you basically have a heating element, hot metal, which goes into the water, creates steam, and steam drives the turbines, which generates the electricity. So what's nuclear about that? Well, we're told that the hot metal is made from this substance uranium, and it heats the water not using normal kind of heat, but using this new nuclear kind of heat they would call thermal neutrons. And this is very, very dangerous. Oh, and you can't go near it, and it's very, very dangerous, but, we can use it to make power. All right. Well, what if it's actually just heat? What if it's not hazardous radioactive particles, but it's just harmless radiant energy? What if the metal uranium is able to store and release heat over a long period of time, and that's why it's good for using to generate steam? These things make sense to me, right? A metal that can hold heat and release it slowly over a long period of time. That's all that's happening here, right? The water is being heated by metal rods. Again, they will take you into the quantum world in order to bamboozle you. So if you say, like, how does nuclear power work? They'll be like, oh, well, the uranium atoms will spit out a neutron, and the neutron will split the other uranium atoms, and they will, like, bush out and split others and stuff. And, like, guys, that's all, like, stuff for the blackboard, right? That's all on the blackboard or in the textbooks. It's not in the real world. A chain reaction, if you really think about it, what is a chain reaction? A chain reaction is when something burns. Right? It's when something burns continuously. It burns and it keeps on burning. That's a chain reaction. Okay, so what about the atomic age then? So we're told we live in the atomic age. Actually, since 1945, since these bombs were dropped, we now entered into a new age of humanity, which is defined by this problem of the atomic dilemma, which is the idea that basically the Americans or the Russians or the Chinese or, someone's going to just like push a button one day and blow up the entire world, right? This was not something people worried about prior to 1945. But because this is such a serious problem, we now have a whole new age of humanity, which is named under the atom, the atomic age. But, we know that these political classes like to just keep us afraid. They want to just scare us all the time. They want to think we've got enemies all over the place that are trying to kill us, and we need their protection from and everything. So, they really ramp this up, as you will have seen in recent years. Like when they really want the people to be scared, they just ramp up all this stuff. They'll bring up nuclear war every week on the news. There'll be some new disease, or they're just always trying to scare you. And so the atomic age and the threat of nuclear annihilation is, again, it's one of these cards. The threat of nuclear annihilation is one of these cards that the controllers of the world like to bring out and play from time to time. Okay, the Radium Girls. This is a highly publicized and popularized story. I think there's even a Netflix documentary about it. I haven't seen it, but It's all over, all the magazines and mainstream newspapers and all this kind of stuff. They bring it up again every so often because it's part of the propaganda. But the Radium Girls story is this story about some female factory workers who were working with radium paint. They were like painting on clocks to make the clocks glow in the dark. And apparently they were licking the paintbrush and dipping it in the radium paint and then putting it on the clock. And apparently this led to them completely, getting horribly sick and all their, bodies like falling to pieces, like jaws falling off and all this kind of stuff. And then, so this was used as a nuclear scare story and to take radium off the shelves. Radium had been used actually for lots of things. About 100 years ago, it was like on the market and it was, widely hailed as this kind of like miracle substance. But then due to the Radium Girls story, it's like, no one can get radium anymore. Not safe. Okay. Well, cold fusion. Flashman and Pons. So, this two guys in 1989 who claimed to have fused nuclei together without even using heat. So cold. They'd done it cold. Fusing two nuclei together. And when you fuse two nuclei together, you get a flash. And it's funny, his name's Flashman. Fleischmann. It looks like Fleischmann, but it's sort of pronounced Flashman. And of course, Pons is a part of the brain, which is a bit weird. But anyway, Flashman and Pons in 1989 fused two nuclei together and got a flash. And then nobody was ever able to reproduce their results ever because it was actually a complete fraud. Though some people will say it was incompetence, but it was fraud. Okay, so hot fusion, right? This is the idea of these over unity power generation stations. Again, another type of vaporware. If you go and look up like nuclear fusion reactors, you'll find lots of promises that there's, ones in the works. They're being developed at the moment. They're going to be online by 2030 or 2035 or 2040 or something like that. And, again, it was the same thing 30 years ago, right? It's always 5 years, 10 years ahead. It never materializes. It's just on the horizon. It's vaporware. Fukushima. All right, a well-funded and calculated disinformation campaign. And I'll give you a link for more information about all that. But definitely was not what the hysteria on the news claimed was going on there. Similarly with Chernobyl, a lot of hysteria around that as well. But it actually kept operating for 14 years after the disaster. And although, there was evidence of poisoning, which was later attributed to iodine, there's no evidence of nuclear radioactivity or nuclear fallout. And again, you need to look into a lot of this stuff yourself, right? I'm just summarizing my opinions on it, but, don't take my word for it. Go and look into all this stuff, right? There's people living at Chernobyl now, and they'll tell you about it. It's, there was a hysteria, a nuclear hysteria, but it was unjustified, because there was nothing nuclear actually going on. Particle accelerators. Okay, so I've been to particle accelerators. I've worked in particle accelerators, and I don't believe that they are accelerating particles. It's electricity, guys, right? If you look into how a particle accelerator works, it's a cathode ray. It's basically a giant cathode ray tube. And they can make it like feedback so that it gets like stronger and stronger, which would be like the acceleration. Best way to think of this is like an audio delay. You play with an audio delay. If you turn the feedback up above 100%, it's like delay, 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 delay. It gets like louder and louder, like starts like, until it like saturates the energy. This is what's happening in these so-called particle accelerators. It's, it's electricity. Again, look into that stuff yourself. I would also say as well that nothing good has ever come from a particle accelerator. For what is potentially one of the biggest, most expensive machines that money can buy, it doesn't actually produce anything. And this is the issue, right? It's like, if you're going to build big machines, at least make them useful machines. All right, and then stars. Okay, so now obviously I'm not saying stars are fake. We can see them with our eyes. Stars exist. But we're told that they are ginormous nuclear fusion reactors manufacturing matter in outer space. And I just do not believe that. So this is astrophysics. And that was actually the subject of my degree, was astrophysics. And in the third year, I switched to theoretical physics because astrophysics is so boring. Guys, I mean, the stars are so fascinating and mysterious, and there's so much we can learn from looking at the heavens. Astrophysics is a massive distraction from that, and it's a very unsatisfying science. Essentially, it's nuclear theory in outer space. So, by making the assumption that the stars are themselves nuclear reactors, it allows nuclear theory to just run wild with its imagination and pretend like the whole entire cosmos is made up of giant nuclear reactors like hanging about in outer space together, manufacturing planets and all this kind of thing. It's just like pure sci-fi. Okay, so there's 10 nuclear hoaxes. There's more, but those are 10 of my favorites. And yeah, so here's a link. I know it's a bit of a long one, but you can figure it out. It's just a resource where they've gathered like tons and tons and tons of articles about nuclear radiation hysteria and all the fakery and the media lies, and how it is that people end up believing a lot of this stuff. It's a lot to do with just fear mongering and hysteria. Let's talk about logic then. So there's a lot of logical fallacies in quantum physics, and in most modern science now, because the theorists and the academics and the media and everything have just been allowed to just say whatever they want, so there's just lots of fallacies that just go unchecked and just get repeated over and over again. So let's just look into that. So we got like the bandwagon and the appeal to authority fallacy, right? So everyone knows atoms exist. Einstein proved it in 1905. So this is the bandwagon. Everyone knows atoms exist. Okay, so there's essentially this big bandwagon in the world of people who believe in atoms, and they are basically everyone. And because everyone knows it, it must be true, is of course a logical fallacy. And then Einstein proved it in 1905. Well, if you actually looked into it, you'd see that Einstein didn't prove anything. But just saying Einstein proved it in 1905 is an appeal to authority fallacy, because Einstein is considered the highest authority in modern physics. And so if he said it, it must be true. Right, the reification fallacy. This is a good one. Atoms and molecules are real because we have precise models of them. Now, this is a tricky one because it's used a lot. In other words, we think that because we have very sophisticated and precise models of something, that it must be real. But again, it's a fallacy, right? The reification fallacy is when you believe something abstract to be something concrete. And, this is the theory of gravity, the theory of atoms, the theory of subatomic particles, the theory of quarks, the theory of electrons, the theory of point charges. All these things are abstract, things that were defined on a piece of paper. And we've talked about them so much, we now believe them to be real, right? It's a reification fallacy. What about affirming the consequent? That's a good one. So this is the Brownian motion fallacy. So atoms cause things to wiggle. Therefore, if we see things wiggling, it must be caused by atoms. You see, you're affirming the consequent. It's, another logical fallacy. Hasty generalization. Right, this is when you take something and then you generalize it very quickly into something huge. This would be like saying the double slit experiment proves that we have infinite parallel selves in alternate realities, and cats can be dead and alive at once. So you see how, we went from this double slit experiment, which actually all it proves is that light is a wave, but based on how they generalized that double slit experiment, they end up concluding that there's parallel realities and we have infinite parallel selves, and that the cat in the box is like dead and alive at the same time, or that the electrons split up and interfere. You see what I mean? There's just all this like crazy stuff just from analyzing this experiment, which shows only that light is a wave. That's it. It's just a simple demonstration to show that light is a wave. Circular reasoning. Well, quantum mechanics can only be understood by the smartest people. Therefore, those who understand quantum mechanics must be the smartest people. Yeah, I kind of fell for that one. And then ad hominem. So Stephen Young cannot be trusted. He's just a DJ who took too many drugs and lost the plot. So I get that one quite a lot. But again, it's like ad hominem is what people use when they've got nothing, nothing good to say, nothing they can argue. They just attack your character or try to make you out to be a fraud or a fake or something like that. It's pretty weak. Ad hominems are weak. Okay, so let's talk about this then. This is the Solvay Conference, famous photograph from 1927, which shows all of the quantum physicists, all the sort of most famous ones, all together in a picture there. And it's been called the most intelligent photograph ever taken, which is quite funny. And I probably believed that at one time, that, somehow this photograph captured the greatest, the cream of the cream of humanity's intelligentsia. But I started to break down a lot of this stuff. More and more I started to think, really, what is going on here? Who the hell are these people? Who brought them together? For what purpose? Who funded all this? Why so much energy given to quantum theory? Tons of Nobel Prizes, all this stuff, but no applications. It's just not good business, right? To put lots of money into something which is not making any money, which is not capable of making any money because it has no technological applications. Anyway, I started looking into it and looking into the lives of these people, and it was, let's find out a little bit about some of them, but nothing all that interesting. And people like Einstein and Schrödinger have got quite colorful lives, let's say. But eventually it just sort of hit me, the names. What do the names mean, right? They actually, a lot of these names are pretty strange. And I started looking into them to see if they were common, because they all sort of sound like, German, French, Austrian kind of names for the most part. But these are not common names at all. A few of them perhaps, like Wilson or Richardson. But for the most part, the names are actually very strange and uncommon. So I started looking into the etymology, breaking down the names, and finding out what they actually mean. And it's sort of revealed quite an interesting pattern. Now, Einstein means one stone. And immediately this struck me because there's this thing in Freemasonry called the foundation stone, right? Which is the first stone that is laid before the building of a structure. like a house or a cathedral or anything, there's one stone that has to be laid before all the others. It'd be called the cornerstone or the foundation stone, the first stone or the one stone. Now, Einstein, one stone, is actually the foundation stone of the whole of modern physics. Right? That's why he's the highest authority, the highest perceived expert in physics is Einstein. And his theories, relativity, E equals mc squared, Brownian motion, all that, they're all used to underpin the whole of 20th century physics, basically. So Einstein is the foundation stone of 20th century physics. Plank. Now, it's a flat piece of wood. A long piece of wood smoothed with square edges. It's basically a piece of wood that's been prepared for building with. So yeah, another interesting thing, because you got the one stone, which is the first stone in the building, and then you got plank. It's actually max Planck as well, which means a lot of planks, or the greatest number of planks. So there's a sort of building connection here, and of course masonry means builder, right? So bore, as in Niels Bohr, bore means to drill a hole or to create monotony or lack of interest, like to bore someone. So I hope I'm not boring you, by the way. Yeah, Niels Bohr. Strange name. It's not a common name. Born. So in 1923, there was a paper by a guy called Max Born, and that was the first time the word quantum mechanics was used. So in German, it was Quantenmechanik. And so, yeah, quantum mechanics was born from the mind of Born, a guy called Born. All right. It was brought into life, you could say, by a man named Born. Then you've got poly, as in Wolfgang Pauli. Well, poly means small or tiny, like the tiny little quantum particles that he was studying. So that's amazing, right? It's like the guy is in the right business. He's studies the smallest things in the universe, and his name means small or tiny. Then you've got Dirac, Paul Dirac. Now, I traced this back to the old French dire, meaning tear. And Dirac means to split, rend, or tear into tiny pieces. I think that's quite interesting as well, because in many ways that's what quantum mechanics is. As you remember, I said earlier, right? The first thing they did was they got cathode rays, J.J. Thomson, and said those were made up of little pieces. And then with the quantization of energy, saying that light is made up from little pieces as well. And of course, the atomic theory is that matter is made up from these little pieces. So you see, the quantum physicists are sort of tearing up reality into little pieces and then defining those little pieces super precisely. Now, Schrödinger, crazily enough, means one who shreds or cuts things into small pieces. It comes from the word Schröding, which means shredding, or relates to cloth cutting or being a tailor. So, cutting up cloth into little squares and stuff. Yeah, mind-blowing. So Heisenberg, I think means hot mountain or burnt mountain. I don't know. It doesn't really make that much sense, Heisenberg. I think it could come from the German Heisen, meaning hot or burnt. Berg means mountain or hill. Someone suggested to me it could be Eisen. If the H was silent, it could be Eisen mountain, which would be iron mountain. But yeah, I'm not sure quite how that relates to quantum physics. But again, not a common name. There's Broglie, as in de Broglie, who came up with the wave-particle duality, the de Broglie equation. Broglie is a small private wood, like an enclosed meadow, like a fenced area or a park. Okay. Bohm. Now, we talked about Bohm and his interpretation of quantum mechanics. Well, Bohm is actually short for bohemian. And a bohemian is like one who rejects rigid materialism and embraces a creative, artistic lifestyle, right? So that was me at one point in my life. And I said, that David Bohm's interpretation of quantum physics was my favorite, right? And it's actually because it is the bohemian interpretation. It's the one that's most appealing to artists and people with a more spiritual bent. Feynman. Now, he wasn't in the picture, but everyone's heard of Richard Feynman. Everyone likes him. Well, it means fine man. So Feynman is just exactly what it says on the tin, right? It means fine man or good guy. There's brag as well, as in brag scattering. Okay, brag means to boast or talk with excessive pride, which these people certainly like to do. And brilluine, which is a good one. It means brilliant one or bright/shining one. Wonder how you get a name like that, hey? And then finally, the only woman in the picture, Marie Curie. Well, some have suggested this is Mercury. There's a lot of talk about this. She had left some clue in her journal as well about this, about relationship to Mercury and Mercurius. That was like the Roman name for Mercury was like Mercurius, and she wrote something about the importance of being more curious. There's more to dive into in Marie Curie. I haven't done a proper deep dive on it. I noticed there's a new movie out about her on Amazon, and I believe as well there's a whole Crow 777 episode devoted to this issue of Marie Curie and Mercury. So it's a thing, but yeah, obviously the name sounds very similar. This could all mean nothing. Again, I mean, make up your own mind here. You can go and verify any of this yourself. But it starts to look like they've all got made up names. Which is strange for a scientist, right? I mean, fair enough if you're a musician or an artist, a performer of some kind, you may have a stage name, as I have. But if you're doing fundamental science, why you got a fake name? That's really disingenuous. And so, yeah, it seems to suggest that there's something more going on here than just a bunch of men trying to figure out, trying to honestly figure out how the world works. There seems to be something more going on here. Aristotle also has an interesting name. Aristo means greatest or best, and tel means purpose. So the greatest purpose, or the best purpose, or the highest purpose. This is a pretty great name to have, right? It doesn't sound like the kind of name you would be given at birth. It's, either something that you choose yourself, like a stage name, or a name that was made up later in history. Just not sure, to be honest. But, this theme of these sort of made up names for scientists and philosophers does seem to go back a long way. Now, Aristotle, I must admit, I didn't know much about at all. I wasn't trained in Aristotle in all my education. But then I started looking into some of the stuff that Aristotle said. I found that this fire, earth, air, and water is attributed to him. Of course, he didn't come up with fire, earth, air, and water. There's always been fire, earth, air, and water in creation, like since the very beginning. But, he talked about it and he worked with it and worked with the symbols, the triangle symbols and stuff. He said a lot of interesting things about philosophy and physics and politics and so on. But, we also have to be careful not to idolize these people just because they're ancient figures. As I understand it, Aristotle was actually a glober as well. So there is that. He believed in a geocentric globe, so a stationary Earth globe at the center of all creation. Nobody's perfect, hey? All right, let's talk about Schrödinger's cat. So this is probably one of the most famous Gedanken experiments. This is a thought experiment. As far as I know, it's never actually been done in a laboratory. But the idea is that there's a cat in a box with a quantum death machine. All right, so what is a quantum death machine? Well, it's basically a gun or a poison release mechanism, which is wired up to this quantum device, which will trigger when a certain type of quantum event happens. And because quantum events happen randomly, it's essentially a random trigger generator. So it's something that connects the quantum world with the real world. It's kind of a paradox and a riddle. And the idea is that it sort of blurs the lines between the quantum and the real. So the claim is that when the cat is sealed in the box with the quantum death machine, it then enters into a state where there's a probability that the cat is dead and a probability that the cat is still alive. And they say that because we don't know if the cat is dead or alive, that the cat is in a superposition of states of being dead and alive at the same time. That is, until we open the box and observe the cat to be either dead or alive, until that point it's in a quantum state, a quantum wave function where it's dead and alive at the same time. So it's pretty mental. It's got to be said. It's pretty crazy stuff, but it really sort of challenges your conception of reality and gets you thinking in completely different ways. Now, it's often joked about. It's sort of a humorous thought experiment as well, but it's not actually just harmless intellectualizing. I would say it's actually a kind of a covert initiation into solipsism. So what is solipsism? Well, it's basically the idea that everything is a hallucination, that your mind is the only real mind, and everybody else, everything else is being created by your mind, like in a dream. And it's the idea that reality isn't real when you're not looking at it. So again, when you look away, things go into this like wave function type state, like the cat. But when you look at it, your observation collapses it from this wavy quantum state into reality. Now, that's solipsism. And really it's the idea that other beings are figments of your imagination. This comes from the Latin words solus, alone, and ipse, meaning self. So it's the idea that you alone are the only self in the universe. Everything is just being generated by your mind, and all the other people are just characters in your dream. You're the only real one. So this is really what you're being conditioned with when you contemplate Schrödinger's cat. You're being kind of initiated into that kind of solipsistic mentality the longer you ponder this. And, it gets even more sinister when you learn that Schrödinger himself was a known PDF file and quite a predatory person, very cruel to children and probably cruel to cats as well. And, this isn't just a conspiracy. I mean, it's on his Wikipedia. He's had his name removed from certain institutes and buildings because of his sexual exploits and all that. So, Schrödinger was not a well man. And but we're taught about the Schrödinger equation and Schrödinger's cat in university as if it's, as if he's like this legend. But guys, none of this is useful or healthy to be thinking about. And believe me, I've been way down the rabbit hole on this. And, I have been in states of mind where I would say I was in a solipsistic place where I thought I was the only real mind. It's not healthy. And, quantum physics is kind of indoctrinating you into that kind of mentality. So you got to be careful. And, it's worth noting that one of the most famous quotes attributed to Erwin Schrödinger is when he said, "The total number of minds in the universe is one." Now, when I first heard this quote, I thought it was a statement about God. I thought he was essentially admitting God is real, in that, we all are creations of the mind of God. But now, I think he was actually talking about himself when he says the total number of minds in the universe is one. He means him. Like, he's the only one, only real one in the universe. So that is the dangers of solipsism. And of course, with him being a child predator, having a solipsistic mentality would be beneficial, let's say, to someone who's engaging in that type of behavior, because, as I say, it erodes empathy. So, no empathy for his victims, of course, because they're not real minds. Anyway, moving on. Solipsism is a philosophy, I suppose, a belief system that is kind of hidden throughout all of this quantum stuff. It's paradoxical and self-refuting, denies objective reality, impractical for daily life, because to actually live your life, you have to treat other people as if they are real. So it's totally impractical to believe that other people are not real. It can't be proven or disproven, so it's unfalsifiable, so it could just drive you crazy. It negatively impacts your relationships, of course. There's this problem of other minds, right? It's like constantly a problem if you believe that everyone else is just fake or a figment. It's philosophically isolating. It detaches you from reality, and there's an erosion of empathy that happens when you go down this path. It's antisocial, amoral, and anti-life, ultimately. It just doesn't have respect for life, because it's just everything is seen as being just a sort of mental fiction. Paranoia, delusions of grandeur, apathy, psychopathy, and nihilism. And these are all, well-known consequences of solipsism, right? So, to me, a lot of this quantum philosophizing is really just conditioning people into this kind of a mentality. Now, what about then the theory of quantum physics? Well, particles and paradoxes, right? The theory is all about particles, which have never been proven to exist, and it's riddled with paradoxes. So here's just 10 of them. There are more, but there's the wave-particle duality, Schrödinger's cat, quantum entanglement, or the EPR paradox, the measurement problem, the quantum Zeno effect, the delayed choice experiment, quantum tunneling, many worlds interpretation, quantum superposition, and the information paradox in black holes. You can look these up yourself if you're interested, but I wouldn't recommend it. But basically, all these things are paradoxes. Paradox, the word means contrary to expectation, or contrary to what you would think. So they're all things that are actually completely contrary to not only common sense, but just, logic, reason, and reality. And in my view, none of them have really been proven in any satisfactory way. It's all misinterpretation, right? They're misinterpreting the mathematics. But there is a practice of quantum physics as well. And the practice, is more practical. And it actually works pretty well at predicting the outcomes of measurements. So, as I say, that's why I say, like, not everything in my PhD is bullshit, and I'm not just saying that. It's true. It's because it was practical. Yes, there's a lot of speculation in there, like mathematical speculation, but in the end, I did a practical calculation that predicted the outcome of an experiment, which was done by some people in a laboratory. So it does work in that effect of predicting the outcomes of measurements. Now, the reason it does is because it utilizes wave functions. All right, so these are wave functions. These are said to be the wave functions of hydrogen. But really, what are wave functions? It's literally just sine waves. Sine wave, mathematical function, like added together and modeled in 3 dimensions. So usually when we see a sine wave, we see it in 1 dimension. But you can do them mathematically in 3 dimensions or even more dimensions if you like. And by adding sine waves together, you can create any shape, any shape, basically. So this is called Fourier synthesis, or Fourier's theorem, and it works very, very well at describing reality. And as I say, it's really the same math that goes on inside a synthesizer. It's all wave equations and harmonic science. The principle of harmony is very important. So actually atoms, atomic states, nuclei, nuclear states, all of that are all modeled with waveforms. They're like musical chords. And the wave theory is so accurate that it can actually be used to predict the outcome of measurements. And it doesn't matter if all these people with false names made all these crazy misinterpretations of what the wave function is. The wave theory still works at doing calculations. You see, it's so there is practical use to quantum physics, and when people are doing practical quantum physics, they are actually doing calculations which are rigorous and correct. But the philosophy and the theorizing and the interpretation of quantum physics is just wild and rooted in mental illness, I would say. So I hope you understand the difference between the theory and the practice and the philosophy. That's really the point I want to make here. So these are called spherical harmonics, and again, like I say, it's just sine waves which have been added together, and it's in 3 dimensions. So if you look basically at the most basic one at the top is just a sphere, but then the next ones up, they look like a tube torus, like a toroidal field. And then you go to higher excited states. These are like higher harmonics. So you're like adding more harmonics into the vibration and then integrating it in 3 dimensions. With these you can create any kind of like dynamic shape. So these harmonics, harmonic science and wave theory does work very well at describing energy and matter. And so it's important to understand that, right? When I'm criticizing all the theory and the philosophy stuff, that there is actually still a core of useful physics within there that can be used to predict stuff and model stuff. Now, I like this quote from Manly P. Hall. He said, "We are the gods of the atoms that make up ourselves, but we are also the atoms of the gods that make up the universe." So the word God is synonymous with source, creator, origin. So when he says we are the gods of the atoms, he's saying we are the creators of the atoms. We are the origin of the atoms. So the atoms are just something that we made up. It's a theory that we made up. Now, idolatry. I would say that the atom is more than just a theory. It's actually an idol. Now, how do we know it's an idol? Well, it's a false image or representation of God. Excessively loved, feared, and admired. Has the power to create and destroy worlds. Yeah, think about that. So we're told that the whole universe came about from the atoms. So the atoms have the power to create the universe. And then we're also told that when we have the power over atoms, the atomic bomb, we could destroy the whole world. Yeah, so the atom has within it the power to create and destroy worlds, which is a divine power. So it's structured as a trinity as well. So as you know, God is structured and usually represented as a trinity or a triangle, as the Father, the Son, the Holy Spirit. Well, the atom is also structured as a trinity, which is the electron, proton, and neutron. And it corresponds. So it contains both genders. So positive and negative. Positive is masculine gender, negative is feminine gender. And likewise, God created man and woman in his own image. So God contains both genders within. It hides the ether and transmutation. So, this is a whole other thing if I, get into the alchemy of quantum physics, which I'll do for another presentation. But it hides the ether. So before people believed in atoms, they believed in ether. And the atomic theory kind of masked the ether and hid it, and it's kind of like occulted it and covered it up. And it also hides transmutation. The idea that one material, one metal, can be transmuted into another kind through the application of heat. That has been thrown out of science. That's now taboo. And we're told that every metal is a specific type of atom, and that you can't turn one type of atom into another type of atom. So it hides ether and it hides transmutation. So it's antithetical to alchemy as well. I mean, to the point where, I actually started to wonder whether the whole thing was just made up entirely to hide alchemy. It was just like they just invented quantum physics with the purposes of hiding alchemy, because it's so antithetical to everything in alchemy. It's like an inversion. And of course, it's used by governments to scare you. Right, so they wave it, the atom in your face every time they use the word nuclear or atomic to scare you. That's that's what they're doing. So the atom is an idol. And interestingly, if you look at the symbol for the atom, it's actually the same as the symbol for the ether, just slightly tweaked. So the ether is symbolized by the two triangles, the upward pointing triangle, which is the masculine energy, the phallus, and the downward pointing triangle, which is the feminine energy and the womb. Overlaid together in one harmonic shape symbolizes the ether. So fire and air, water and earth, and then ether when it's all together. And I know you've probably seen this symbol on certain flags. Well, it's only been used on the Israel flag since 1948, and it was only adopted as a symbol of Zionism in 1897. But as a symbol of ether, it goes back thousands of years. The atom, on the other hand, is a new symbol that's just been in use since around about 1945, or just after the Second World War. And if you overlay these on top of each other, you see it's the same thing. It's a hexagram. It's the same symbol, just tweaked slightly. All right, well, in conclusion then, quantum physics. Well, it's a complex 20th century version of ancient atomism. It is bizarre and illogical and makes unfalsifiable and unverifiable claims. It fails to prove the existence of the particles that it claims to describe. And there's been over 100 years of talk about it with no tangible benefit to humanity. Philosophically, it's rooted in idolatry, materialism, nihilism, and hedonism. Theoretically, it is riddled with misinterpretation and paradoxes and can lead to solipsism. Practically, it has some ability to model energy and matter because wave equations describe reality irrespective of particles, paradoxes, and misinterpretation. Okay, so all the talk about quantum particles and all the different flavors of particles and the atoms and all that, the wave equations work regardless of all that, right? That's all just speculation. It's just pure hypothesizing, misinterpreting the wave equations. They believe the wave equations to be probability distributions, but they're not. They're just waves. Waves, that's it. And they're misinterpreting these waves as probability distributions and then making all kinds of bizarre reality-bending claims on that basis. So the Copenhagen interpretation, well, they said it best, really. They said, just shut up and calculate. Don't philosophize. Don't theorize. Literally just do the calculations because that's all it's good for. It's just a tool for predicting the outcomes of measurements. Nothing more. And, I would say a lot of it is fruitless pedagogy and intellectual posturing. So this word pedagogy or pedagogical is quite interesting. It means, peda is from pedo, meaning child, and goji or gogic is leader or leading. So it's child leading. Pedagogical means child leading or for the purposes of leading children. So it's usually means like of or relating to teaching. So something is pedagogical if it is made purely for the purposes of occupying students' minds. And I think what I found is that a lot of the stuff we're taught at school and university is just pedagogical. It actually has no use in the outside world. You're not being given a skill. You're just thinking over things and doing things that are just made up purely for the purpose of occupying your mind and keeping you busy while you're in the government daycare center. It's you obviously you do learn some useful things at school and university as well, but a large chunk of it is fruitless pedagogy that will never be any use to you in any real situation. And then there's intellectual posturing, and this is where people will use quantum theory to position themselves in such a way as to appear to have knowledge of, this quantum world or whatever, to appear to have some higher knowledge of this bizarre other dimension that nobody understands, right? It's kind of like a posturing, and because it's so bizarre and because it's so hard to comprehend, a lot of people will fall for it, and they'll just get bamboozled. And again, I've been there. I know how this works. So I hope this just helps you to discern more when people are talking about atoms and molecules and quanta and all this kind of stuff. You can have more discernment and able to extract more meaning from things and know when somebody is just giving you information that's absolutely no use whatsoever. Because it happens a lot. All right. Well, I hope that was good. I hope you enjoyed. Hi, everyone. Just want to let you know that I've now set up a Patreon. So this gives you an opportunity to become a patron of me in exchange for some exclusive benefits. So if that sounds like something you'd be interested in, check out the link in the description.